In this video, we're going to calculate the covariance, correlation, slope, and y-intercept. You need to make sure you have these down. You'll be using these on the test. Also help you understand the concepts of correlation and regression. Okay, so we start with observations for two variables, x and y. So when x is 6, y is 9, x is 8, y is 3, and so on. You can see I've gone ahead and summed the x's and y's at the bottom to get to 30 and 35. I did that so I can compute the means for both x and y. Should be familiar with these formulas by now. Then I'm going to compute the deviations. So 6 minus 6 is 0, and so on. 9 minus 7 is 2, and so on. So I have the deviations for both the x's and the y's. Of course, the sum of each of those is going to be 0. Now I'm going to obtain and sum cross products. So what I'm doing is I'm going to take each deviation for x and multiply it by each deviation for y. So you can say I have 0 times 2 is 0, 2 times minus 4 is minus 8. And you can say I have summed those down at the bottom. So that's a minus 23. That's minus. That means my slope's going to be also minus, and we're going to have a downhill run. If it were positive, we'd have a positive slope and an uphill run. So to compute the sample covariance, take that sum of cross products that we just had, the minus 23, divide it by n minus 1. So it's minus 5.75. So now I'm going to sum and square deviations for both x and y, just like I would I'm going to calculate the standard deviations. So I sum and square the deviations for both x and y. You can see I have 26 and 34. Then I want to calculate the standard deviations for both x and y using the formulas we've been using for a while. Standard deviation for x is 2.55, and the standard deviation for y is 2.92. So to compute the correlation coefficient, I'll take that covariance, which we had minus 0.575, divide that by the product of the two standard deviations, and I get minus 0.77. That's a fairly or moderately strong negative correlation. Remember, the correlations vary from minus 1, which is a perfect negative relationship, to positive 1, which is a perfect positive relationship, 0 being no relationship. So anyway, this will have a downward slope, not perfect, but still at least moderately high. So now we're going to calculate the slope and the y-intercept. Slope, b, is equal to the covariance of x and y divided by the variance for x. And the y-intercept, a, is equal to y bar, that's the mean y, minus the slope, which we just calculated, times x bar. So the slope then, again the covariance divided by the variance, minus 5.75 divided by 2.55 squared is minus 0.88. So for every unit x goes up, y will decrease by about minus 0.88. And then we'll cross the y-intercept at about 12.28.